and welcome to part 2 of our Completing the Square series and part 8 of our Quadratic series. In this part we're going to explore completing the square with non-monic quadratics, but I can't emphasize enough that the previous video is the cornerstone to this process. So you need to be able to do the completing the square method on monic quadratics to be able to do this part. In video 3 we'll introduce solving equations using completing the square method. So this one I'm going to do purely through examples. Example 1. 2x squared plus 8x. So here's an example of a non-monic quadratic. Just remember, non-monic means that there is a non-unitary value in front of the x squared. So it's not 1x squared, it's 2x squared or 10x squared or 100x squared or negative 5x squared, for example. So the trick to non-monic quadratics is quite simple actually, is that we take that 2x squared plus 8x and we recognise we'd really like to work with a monic quadratic. So I write it down as 2x squared plus 4x. We're simply factorising out the coefficient of x squared. And we're going to do that every time. Now we go on the inside here and we complete the square on this inside function. So it becomes x plus 2 squared, because our b value is 4 and half of 4 is 2. But then we have to subtract that 2 squared. And that is based on our previous work. It also takes away the additional 2 squared that we'll get when we expand that x plus 2 squared. And so this becomes 2x plus 2 squared minus 4. But we'll do one final step and just expand this out. And we get this. 2x plus 2 squared minus 8. And there's our final completed square form for the original function, 2x squared plus 8x. And of course you could re-expand this to see if it actually works. And example 2. Of course you can always stop now and re-watch that first example to help you build on the second one, etc. So this one is just not going to be quite as nice numerically. 5x squared minus 8x. I factorise out the 5 first of all to give me x squared minus 8 over 5x. And so the idea here being that I want to get that unitary quadratic. And now I write this down as x minus 4 over 5 squared. 4 over 5 being half of 8 over 5. And I subtract from that 4 over 5 squared. Now it's looking a little bit complex, so I'm going to try and deal with some of these fractions. I've got 5. I can't deal with the first one. X minus 4 over 5 has to remain squared. But the second one looks like this, 16 over 25. And I'm going to leave it like that. I could simplify that, but I'll leave it like that for now and stick with fractions. And now, of course, I do that expansion again. So 5x minus 4 over 5 squared, and then minus 5 times 16 over 25. I don't want to rush this, but I want you to see that this is 5x minus 4 over 5 squared minus 16 over 5, which of course is 3.2 if you wanted to do that. And so there's our completing the square in that second example where the numbers aren't quite as nice, but you know the process is the same. Hopefully you can see that it's not too bad. Example 3. 3x squared plus 15x minus 7. So we're going to complete the square on this quadratic expression. So we follow the same process again, except this time the minus 7 is just an additional constant term, and we just ignore it to start with. So I'm going to start by removing that 3. X squared plus 5x is what it is when it's factorised, and I'll leave out the minus 7. And now that I've done that, I can complete the square on that inside term. 3x plus 5 over 2 squared minus 5 over 2 squared, close brackets, minus 7. And now I can expand that whilst also simplifying this negative 5 over 2 squared. So I get 3x plus 5 over 2 squared, and then minus 3 times 25 over 4 minus 7, And so you see we're going to get a number on the end that we can combine together. 3x plus 5 over 2 all squared minus 75 over 4 minus 28 over 4. Now you'll have a calculator, so you could probably do a lot of this on your calculator, but this may be in the non-calculator exam. And then we get 3x plus 5 over 2 squared minus, and 75 and 28 make 103 over 4. And that's really the best that we can do. And so there we have it, completing the square on an even more complex term. And one more example for you. Example 4, completing the square on non-monics. Negative 10x squared plus 40x plus 328. I've done two things here. First of all, I've introduced that negative coefficient of x squared. And secondly, I just want to show you that it really doesn't matter how big, small, or obscure the constant term is. So negative 10x squared plus 40x gets factorised to give me negative 10 x squared minus 4x. So I've factorised out that negative 10 and then plus 328. Now I complete the square on the inside term. Negative 10 x minus 2 being half b is negative 2 squared, and then minus negative 2 squared plus 328, and this is negative 10, and in fact I'm going to do the two steps in one again here. So negative 10 expanding out times by x minus 2 squared, and then negative 2 squared is 4, so it's negative 10 times negative 4, which is positive 40 plus 328, and this is negative 10 x minus 2 squared plus 368. And whilst that looked harder, it was actually easier than example 3 numerically to deal with, so you know that's a good thing. So there you have it, completing the square on non-monics. Now I would like to just also introduce to you a website which I use to look for good ideas of teaching. And it's also a really good website for explaining things to you, and it's worth a look at. And that is www.mathsisfun.com. Really good website, really well explained content, definitely worth a look for this topic and others to just back up this source and get a good idea of what's going on. All the best.